We will continue with the distance time graph for the next case. So example 3, we have the data recorded for a moving vehicle, and I have already plotted the points in the x and y axis in the graph to get a line graph. So time in seconds and distance in meter is plotted in x and y correspondingly, right? And I have already marked the point of intersection. The scale I have chosen is 1 centimeter 1 second, and y 1 centimeter is 10 meter. So the point of intersection for the given data 0, 0, 1, 5, 2, 20 are already marked, and I am getting a line which is not straight. So I am just joining this with a free hand knot to the scale, since I am not getting a straight line, which means the speed is not uniform. So I am getting a line. I have just marked, joined all the point of intersection. So I am getting a line with an increasing slope, right? That is increasing gradient. That is what do you infer from this? The speed increases as the vehicle is moving. So how can you understand by this graph? Now you just take any 2 points. So let us consider 4 and 5 seconds, 4th second and 5th second of the moving vehicle. Now if you just join the 2 points here and here for the 1 second, right? The distance covered, you just note down from 80 to 125. So this is the area, the distance covered area. So from 80 to 125, you see the distance covered is more within 1 second. So just a quite little span, 1 second span of time, the distance covered by the vehicle is more, which means the speed is increasing. So you can find the speed of a vehicle at particular second by just drawing a line, a tangent. You will just learn in your higher classes in detail. The line, for this line we will draw a tangent and find the slope of that in order to find the speed of the vehicle at that particular second. At that instant we will be able to find the speed of the vehicle by using the graph, and that is the purpose of drawing a line graph for the particular data. So if you find the slope of this line by drawing a tangent, a line, you will be able to find the speed of the vehicle at that particular instant, and that you will learn in detail in higher classes. It is enough if you understand that the slope of this line which is obtained is gradually increasing. That is, the speed is increasing. That you can very well understand by just noting these 2 points. So the time gap from within 4 to 5, that is just 1 second, the distance covered, you just see it is more. Similarly, I have marked the data for the next example 4 in another graph, and I have marked the point of intersection by choosing a proper scale, and I have got these points of intersection for the next data that is available. The same distance time graph is plotted, and if you just join the points of intersection, we get a line like this, right? So which means the graph has a decreasing gradient. That is, the slope has a decreasing gradient, which means the speed is decreasing. The speed decreases in this 4th example. So with this data, you will not be able to understand it better. But if you plot as a graph, you will be able to understand in a better manner. That is, in this 4 to 5 second, you just see the time gap. The distance covered is very little. I'm just joining the y-axis between these two. You just see the distance covered. In 1 second, the distance covered is very less. This is the time, and this is the distance covered in 1 second. So you just note down, for 1 second, the distance covered is very less. Whereas in the previous case, for 1 second, the distance covered is more, right? The last one, which means when you compare these two graphs, you can very well understand that the speed is increasing here, whereas the speed is decreasing here. So if you get a slope like this, the speed of the vehicle is decreasing. This is the case where the graph is like this. That is, the line graph is like this. Whereas here, the slope is like this, which means the speed is increasing. Here the speed is decreasing, whereas here the speed is increasing. So by just seeing the slope of the line, we can very well predict whether the object is moving with an increasing speed or with a decreasing speed. And that is the purpose of this line graph. So we have discussed 4 examples where we have an object was at rest, the slope is 0, right? The second example, where we have a uniform speed, that is we got a line. So I'll just draw that and show you. So if you, for the distance time graph, if the distance is plotted here, time is plotted here, right? If you get a graph, line graph like this, the object is at rest. Am I right? Similarly, in the distance time graph, if you get a graph, line graph like this, distance here, time here, then the object is having a uniform speed. The body is moving with a uniform speed, covering equal distance and equal interval of time, right? Similarly, when you get a distance time graph in this manner, right, the speed is increasing. Gradually, it is moving with a higher speed. Similarly, when you get a distance time graph like this, right? So what happens? The distance covered is less towards the journey. That is, the speed is decreasing. So the graph is going in this manner. That is, the graph has a decreasing slope. So the speed decreases. So these are the observations that you have to make. So they will just ask you by giving you a graph, and they will ask you to find out whether the object is having a uniform speed or the increasing speed, or is the object at rest. They will not ask you to plot the graph at this level. Later in your higher classes, you will learn in detail. Hope you followed. Thank you.